Hi everyone, this is Chandan and you are watching the learning field. So here in this video we are going to discuss the rate of convergence of iterative method. Okay, so this is also very important concept of numerical methods, you can say. And how can we calculate the rate of convergence of this iterative method? And one more thing is that is the spectral radius of a matrix. Okay, so the spectral radius is related with the rate of convergence of iterative method. How can we calculate the rate of convergence of iterative methods, and what is the implementation of the spectral radius? So in this video we are going to discuss this thing. Okay, so hope all you are doing well, and those who are new in my channel, please give a like to this video, share with your friends, and our target is 10k as soon as possible. So now let's start. It says the rate of convergence of iterative method is given by v equal to minus log of rho h. Okay, so what is this rho of h? So where rho of h is the spectral radius of h being the iteration matrix. Okay, so iteration matrix, and what is the spectral radius? Now it comes to the spectral radius. It says the largest eigenvalue in modulus is called the spectral radius of a square matrix. So let us take an example first to understand this definition and how can we calculate if the questions comes in the exam that find the rate of convergence of these iteration methods like Gauss-Seidal method or Gauss-Jacobi method. First you see what is the iteration scheme. Okay, iteration scheme. So we all know that the iteration scheme is x to the power k plus 1, this is equal to h x to the power k plus c. Here this h is the what? The iteration matrix. And how can we calculate this iteration matrix for Gauss-Seidal method and Gauss-Jacobi method? I already make separate two videos on that with examples. So you can watch these two videos, that how can we calculate this h and from where or from how the h comes. Okay, so you can see these separate two videos. I will share the link in the description. Okay, so I just write here that for Jacobi method, the h is given by h equal to minus d inverse L plus u. Okay, this is the Jacobi iteration matrix, and C is equal to my d inverse of B. I think I am right. Okay, and for Gauss-Seidal method, Gauss-Seidal method, h equal to what? H equal to minus d plus L inverse into u, and C equal to d plus L inverse into B. If we solve the system Ax equal to B. Okay, if we want to solve the system Ax equal to B, and we can write that A, this is equal to d plus L plus u. You can see these two lectures of how to find the Jacobi iteration matrix and Gauss-Seidal iteration matrix, then you should be very clear about this thing. And I just want to say one times that here A, we write A for this system Ax equal to B as these three matrix, where D is a diagonal matrix, L is a lower triangular matrix, and U is a upper triangular matrix. Okay, and then we calculate the Jacobi iteration matrix. So based on the Jacobi iteration matrix, questions comes in both CSIR NET exam and GATE exam also. Okay, so now if we take an example, and now if we take the matrix as, suppose Ax equal to B is a system we want to solve, where the matrix A is given by 2 minus 1 0 minus 1 2 minus 1 and 0 minus 1 2. So this is suppose the matrix A. Now we first write this matrix as A equal to D plus L plus U, where D is a diagonal matrix, so we can write the matrix D as D equal to just 2 0 0 0 2 0 and 0 0 2. Now L equal to the lower triangular matrix 0 0 0 and -1 0 0 0 -1 0. This is the L matrix. and the U matrix is given by 0 minus 1 0 0 0 minus 1 0 0 0. So this is the three matrix to calculate the Jacobi iteration matrix. Now if we apply the Jacobi method first, now I just say you for this method only how to calculate the rate of convergence. So okay, so if we apply Jacobi method, then what is the iteration matrix? Iteration matrix equal to minus D inverse L plus U. Now what is the D inverse? This is a simple diagonal matrix. So minus D inverse means half 0 0 0 half 0 0 0 half. This is the matrix D, and L plus U matrix means these two matrix sum. So this into 0 minus 1 0 minus 1 0 minus 1 and then again 0 minus 1 0. I think this is the matrix. Okay, now if we product this then we get what? We get here 0 half 0 half 0 half and 0 half 0, this matrix. You can just take once the calculation. Okay, I'll just write it here. Now just a second. If we calculate the eigenvalues of this matrix, so the eigenvalues are given by mod of h minus lambda I, this is equal to 0. This implies minus lambda half 0 0 half minus lambda 0 then 0 half and minus lambda. This determinant, this is equal to 0, and if we break this determinant, then we get minus lambda into lambda square minus half is equal to 0. You can check this to find this calculation. I just keep the calculation here. So now the value of lambda is equal to 0, 1 by root 2 and minus 1 by root 2. So these are the three eigenvalues of the Jacobi iteration matrix. Now we have the spectral radius and we have this term v equal to minus log of this thing. So now what is the spectral radius says? The largest eigenvalue in modulus. That means lambda equal to maximum of mod of lambda i's. Fine. So here 0 half and minus half, then if we take the maximum, then 1 by root 2 is the maximum. Okay, for this case. So this is the rho of lambda, I can say rho of h. This is the spectral radius. Okay, now the rate of convergence for this method Ax equal to b, where h given by, so the rate of convergence of the Jacobi iteration method is v equal to what? Minus log of rho of h means what? 1 by root 2, and this is equal to, if we calculate, then we get like 0.1505 and something other than that. Okay, so this is the complete procedure. So that how can we find the rate of convergence of Jacobi or rate of convergence of iterative method? Okay, so I just take here for Jacobi iteration method the iteration matrix. Okay, you can take this example as Gauss-Seidal method, and in exam if you specify that find the rate of convergence of this Jacobi iteration method or of this Gauss-Seidal method, then you have to just change the procedure to calculate the Jacobi iteration matrix or the Gauss-Seidal iteration matrix. Okay, and two videos to calculate how to calculate the Jacobi iteration matrix and Gauss-Seidal iteration matrix are already done in my channel. I will share the link in the description. You can just check those videos and you can get the complete procedure so that how can you calculate the Jacobi iteration matrix and Gauss-Seidal iteration matrix. And I also on that videos, I think I am also टेक एन एग्जाम्पल ऑफ CSIR नेट एग्जाम और आई थिंक गेट एग्जाम का कोई एक एग्जाम्पल लिया था मैंने, ठीक है. सो आई थिंक यू विल अंडरस्टैंड दिस टॉपिक एंड if this topic is helpful for you, if this concept is helpful for you, then obviously give a like to this video. And one more thing is that this concept is very important for GATE exam, because in the GATE exams, engineering mathematics exams or mathematics statistics, mathematics तो है ही, एंड और भी कई सारे पेपर है जहाँ पर ये सब इटरेशन मैट्रिक्स आई थिंक कुछ कुछ टॉप पेपर्स में है, ठीक है. तो वहाँ से डायरेक्ट यहाँ पर कैलकुलेशन बेस्ड और फॉर्मूला बेस्ड क्वेश्चंस आपको पूछ सकते हैं, ठीक है. So that's why I think this topic is very important. Or if you prepare for any other exams in which this rate of convergence of iterative method in your syllabus, then you can definitely do these types of problems, and you can definitely want to know this concept for your preparation. Okay, so thank you, bye, मिलते हैं अगले वीडियो में, and तब तक के लिए आप ज़्यादा से ज़्यादा सब्सक्राइब कीजिए, ठीक है. 10K कंप्लीट करना है as soon as possible. Okay, thank you, bye, हरे कृष्णा.